Hello students, once again I'm here with types of reactions. We have done two types of reactions that were combination reaction and decomposition reaction. So after completing that two, I am coming to displacement reaction. It is also called single displacement reaction. Why single displacement? I am telling you. But before that, I am giving you account of reactivity series. Reactivity series of metals here I am taking, where metals are placed in the decreasing order of reactivity. So we can say that potassium is having maximum reactivity and then the reactivity is decreasing. Here hydrogen is taken as intermediate. Whatever metals are placed above hydrogen are said to be reactive, while the metals which are placed below hydrogen are said to be least reactive metals. Okay, so I am coming back to this displacement reaction. What is it actually? When more reactive element displaces less reactive element from its compound or from its salt solution. What does it mean? I'm explaining you, students. Like if I'm taking iron needle, iron nail, which is gray in color, iron nail. And if iron nail is dipped in copper sulfate, this is compound or salt solution of metal. So iron when dipped in copper sulfate is blue in color, aqueous form I am taking, blue in color. And when this reaction is taking place, we are getting iron sulfate. What is happening here? Iron, in the reactivity series, you can observe that iron is placed above copper. So, iron is more reactive than copper, and that's why it displaces copper and forms iron sulfate. It itself is getting attached with sulfate after displacing copper. So, single element is getting displaced. And what is the product? FeSO4 and Cu is separating out. Since the color of FeSO4 is light green, that's why the color of copper sulfate fades. And which color is acquired lastly? Light green color. So here I have drawn a figure also for you. Like in a beaker, I am filling blue colored copper sulfate and grey colored iron rod I am dipping it. After some time, it is observed that blue color start fading and light green color is obtained, while the copper which is separating out get deposited here over the iron rod. Reddish brown coating of this copper is appearing. So this is called single displacement or simply displacement reaction. Some more examples I have taken here, students. They are copper sulfate, aqueous solution, blue in color, and zinc when reacting together. Here also zinc is more reactive than copper. That's why the zinc displaces copper and forms ZnSO4, zinc sulfate, and copper is separating out. Here also blue colored copper sulfate is fading and forming colorless solution of ZnSO4 because the ZnSO4 color is colorless. So this is a example of displacement. One more example I am taking, that is zinc when reacting with sulfuric acid, that is H2SO4. Here H is getting displaced by Zn because the Zn is placed above hydrogen. So Zn is replacing this hydrogen. And what is the product? Zn is taking the place of hydrogen. So we are getting ZnSO4 and H2 gas evolving out. One more example, students. Copper. When reacting with silver nitrate is colorless solution. Aqueous solution is there. Here, copper more reactive than silver. Here I have taken both of the metals which are placed below hydrogen, copper and silver. But copper is more reactive than silver. That's why this copper is displacing this silver and forming copper nitrate. And the color of copper nitrate is blue and silver is separating out. Is it clear, students? So these all are the examples of displacement reaction. One more thing which you should note down, that is all the displacement reactions are exothermic in nature. What does it mean, students? Exothermic meaning in this all reactions temperature will rise or heat will evolve out. That's why they are called exothermic reactions. Heat energy is evolving out. Clear? So after this single displacement, now I am taking double displacement reaction. Remember students, these double displacement reactions are also called precipitation reaction because in that precipitate is obtained, and they are also called ion exchange method. Mutual exchange of ion take place. Two elements get displaced. Like here I have written two different atoms or group of atoms get exchanged in the double displacement reaction. So we can define it reaction in which two different atoms or group of atoms get exchanged. The reaction is called double displacement reaction. Most common example of double displacement reaction I am taking here is barium chloride, BaCl2, aqueous form, dissolve in water. When reacting with sodium sulfate, again aqueous, dissolved in water. So sodium sulfate and BaCl2 when reacting together, they are giving white PPT. PPT is a thick substance which is heavier and gets settled down at the bottom. That's why I am writing S here. It is solidifying. So barium sulfate PPT precipitate we are getting. Color is white along with the formation of NaCl here, NaCl. So what you are observing, that two ions are getting exchanged. Barium is taking place of sodium and sodium is taking place of barium. So mutual exchange of ions is taking place in double displacement reaction. One more example, students, like AgNO3 plus NaCl. AgNO3 again colorless, reacting with NaCl aqueous colorless. But when these two are reacting together, we are getting white PPT of AgCl and NaNO3 is separating out. One more example, which is again a very common example, students, and important also, like lead nitrate, which is colorless, aqueous solution, dissolved in water. When reacting with potassium iodide aqueous, Ki, potassium iodide, these two when reacting together, we are getting PPT of lead iodide, and the color of PPT here is yellow, and K potassium NO3 nitrate. What we are getting? Potassium nitrate here in this reaction. So this is one more example of double displacement reaction. Especially these two are very important examples, students. Is it clear, students? Double displacement reaction. Now I am taking next reaction, that is neutralization reaction. Neutralization. Neutral meaning neither acidic nor basic. So this reaction is the reaction of formation of salt, because salts are usually neutral. So what is neutralization reaction? A reaction in which acid reacts with a base to form salt and water. That reaction is called neutralization reaction. So what are the reactants here? One is acid, hydrochloric acid students, and other is base, sodium hydroxide. So acid, when reacting with base, here this is acid and this is base. When acid is reacting with base, we are getting neutral salt, NaCl. This is salt students, table salt, which we take daily. And water is also obtained. Water is also neutral. NaCl, sodium chloride, is also neutral. So reaction in which acid reacts with base to form salt and water, the reaction is called neutralization reaction. Many examples are there. I am taking some more examples. KOH, what is it? Potassium hydroxide. When reacts with HCl, hydrochloric acid, and this is base. When these two reacting together, again a salt, potassium chloride, and water is obtained. Salt and water. Next example I am taking NaOH, that is sodium hydroxide base, sulfuric acid, H2SO4. When reacting together, Na2SO4, that is sodium sulfate, is obtained along with the formation of water. So, NaOH base reacting with H2SO4 acid to give salt, Na2SO4, and water. So, this is also a neutralization reaction. We have taken these examples of which reaction? Neutralization reaction. Clear? Now, the next set of reactions, very, very important. One question will be definitely there in the board exam from this redox reaction. What is the meaning of this redox word? Actually, it is a combination of two words. What are the two words? Reduction and oxidation. So this red is from reduction and ox is from oxidation. So combination of reduction and oxidation is called redox reaction. Firstly, I am telling you the definition of redox reaction. I have not written here that definition, but I am telling you, I am dictating you. You can write it by your own without looking at the board. Reduction and oxidation, if taking place simultaneously, the reaction is called redox reaction. Reduction and oxidation, if taking place simultaneously, एक साथ अगर हो रहे हैं reduction और oxidation, then the reaction is called redox reaction. Before explaining you that what are actually redox reactions, firstly, I am telling you the meaning of oxidation and reduction. Because I know that you are not knowing that what is oxidation, what is reduction. So firstly, we should know about these words, oxidation and reduction. So oxidation, as the name is suggesting, if addition of oxygen is taking place in any reaction, that reaction is called oxidation reaction. This is a definition of oxidation in terms of oxygen. In terms of oxygen, we can define oxidation as addition of oxygen. So we can say all combustion reactions are oxidation reactions. C plus O2, CO2, oxidation. Mg plus O2 gives MgO, oxidation. So what is oxidation? Addition of oxygen. On the other hand, removal of oxygen is reduction. Removal of oxygen is reduction. So by this we can say that oxidation and reduction are reverse of each other. In oxidation, if addition of oxygen is taking place, in reduction, it is getting removed. So reduction and oxidation are reverse of each other. So this is the definition of oxidation in terms of oxygen. If we define oxidation in terms of hydrogen, what is it? Here, removal of hydrogen. If hydrogen is getting removed in the reaction, like if I am saying that CH4, if given electric spark, it breaks into C plus twice of H2. So what is happening? Hydrogen is getting removed. So this reaction is called what? Oxidation. In terms of hydrogen, removal of hydrogen is oxidation. Then reduction will be what? Addition of hydrogen. If hydrogen is getting added in a reaction, then that reaction is called reduction reaction. Suppose if here also I am taking one example, C2H4 if I am taking plus H2. Here what is happening? If these two hydrogen atoms are getting joined with C2H4, what we are getting? C2H6. So this is called what? Reduction. Addition of hydrogen. So I have given you the concept of oxidation and reduction in terms of oxygen and hydrogen. Do it nicely, students. In the next class, I will tell you many examples of redox reaction and I will tell you that how that reactions are redox. Again, I am telling you, students, this is very important topic. Do it nicely and we will meet in the next video with the examples of redox reaction. So till then, goodbye, be safe students, keep studying at home, bye bye.